All right, guys. I wanted to go through. I know we abruptly ended the last video, and I thought we were ready to move on, but I wanted to do one last problem, make sure we had everything sorted out from beginning to end. I was going to use a little bit of different numbers, harder numbers maybe, just so we can see how complicated things could get, but not overly complicating things, okay? So here we go. We're going to sketch the graph. Sketch. I don't like red. Red has such a negative undertone, ladies and gentlemen. I don't think it should be on papers. All right, here we go. So sketch the graph, labeling, and here we go. Here's your instructions. You got to make sure you're always cognizant of it. Labeling vertex, axis of symmetry, and intercepts. And you must already know that there are two types, your X and your Y. Okay, so now moving down, we end up seeing that your guy looks something of a nature that is not as persuasive as you would like it to be, because it is a negative 3x squared plus, let's do a handy dandy 6x plus 1. Okay, that's what he looks like. Okay, so you're like, okay, well, we're going to have to go ahead and we're going to have to complete the square in order to make sure we can determine what the vertex is. All right, good plan. So you say, all right, we're going to push it out. And again, I told you to try to factor it out and give yourself some space simultaneously to save you one step of writing. But if you can't do that, there's no shame in doing what I'm doing right now, which is giving myself some space and then factoring out this -3 out of my grouping here. Which then makes this a negative 2x. And everybody double check my work. I think that's negative 2x, and that's right. Okay, I need some more space. Okay, so here we are. Now the idea is again, we're going to use the -2, and we're going to do some magic on the side. And yes, my little unicorn hat is gone. We got that for the baby shower. Oh, during the baby shower. So apparently it was a unicorn theme, and I got to wear that around. Apparently, go figure. All right, so you take that -2 to the side. That's what this -2 is that one. You divide it by 2, and that is a very important number. That's 1 because that tells you when you square it, that's what number is you're going to be the number that you add it. And again, I'm going to emphasize to you again that this number is different than this one. Okay, they have different purposes, but I'll show you how. Okay, so that black one, that's no big deal. That guy is the guy that's going to get put in. And again, what number do I need to take out? Don't forget that one out here. I always forget that one out there. What number do I need to take out? Well, here we go. That number is really a -3 times 1 is a -3. So therefore, I really put in a -3 to balance out -3, because it has to be 0. It needs a +3. Bazinga. For my visual learners, if you distributed this in, you got -3. To balance it out, I needed a +3, because it must balance out to 0 every single time. Okay? Really that simple. Easy peasy, lemon squeezy. And once we're there, now we're home free. And then this is where the problem can really take off. This will factor out into this. Okay? And the reason it'll factor out into this is because this -1, and I forgot my negative over here, this -1 is that -1. So that's the cool part. Okay, so even if you didn't want to really think about it, you should already know what it should be, +4. Okay, so I would know my vertex would be -1. Well, not -1, the opposite of that. So 1, 4. My axis of symmetry hence would be x equals 1. And then I could do my y-intercept, which if I'm good with mental math, I can plug 0 into x in my head. 0 minus 1 is -1 squared, is still +1. Times -3 gives me a -3, plus 4 gives me 1. No, so no biggie. Okay, that's easy. Okay, now the x-intercepts, I probably can't do that in my head. Now, you guys do know that there is no shame in doing f of 0 and like literally just plugging it in to your guy and working it out. I just think it's some benefit to doing stuff mentally. You end up like getting skills and becoming a better computer in terms of like knowing how values should turn out, and your approximating skills get better. Like no one ever really expects you to work like a calculator, but they expect you to know what numbers should be. That's what makes an engineer. They know what the numbers should be. Right? They become more accountable in a different kind of way versus like, what are the numbers? They're like, no, those are the wrong numbers. I know what they should be. You know, so that's where you kind of want to be at. You only get that way by being good computers. Okay, so you got to get your number sense up. All right, so anyhow, so that's when you plugged in 0. Anywho's, so now we're going to do the other one where we make y 0 and then solve for x. So that gives me 0 equals -3. And I'm going to use one where we completed the square root because that's nice and pretty. -4 equals -3. Oh boy, this is going to be a show. Watch this, guys. Divide this by -3 on both sides. That's right. Because we're isolating for that squared out, boy. 4/3 equals x minus 1. Oh boy, here we go. Y'all ready for it? In order to undo this, we must square root it. Do not forget the plus or minus. Oh boy, it's going to be bad. So, don't forget that. Yes, and guess what? There's a lot of simplification we can be doing, but I'm only going to do a little bit of it because I don't want to have to spend too much time on this. Or maybe I should. I don't know. We'll see. So this ends up giving us this, guys. We get 1 plus or minus the square root of 4, which is 2/3. So that'll be the square root of, square root of 3. And yes, that is ugly. I do not know exactly what that is, but I know it's bigger than 1. So it's like 2 and some change, right? Because this is like less than 1, because if it was square root of 4, it would be 2, right? So it has to be less than 1. So we're adding 1 to, so basically what they're saying, this is 1 plus, so to make it easy, this is like point something, right? Call it 0.7, I guess. So you're going to have 1 plus 0.7 and 1 minus 0.7. So one's a little more than 0, one's a little less than 2. Okay, so anywho's, so you don't need to know exactly where they are, but it's good to be able to approximate. Again, we're talking number sense here a second ago, right? So anyhow, I'm going to leave them exactly how they are. Comma 0, that's one x-intercept, and the other one is this. Okay, so we got those two things that are going on. Now, finally, here we go. So so those are the two. Okay, so bottom line is I got all my info, and now I can finally graph my problem. So let's finish it all out. Here's my graph. 1, 2, 3, 4, 0, 1. Okay, we said one of these guys was a little bit bigger than, hold on. 0.7 is 0.3. That can't be right. 0, 1, 1, 4. Aha! I found it. I always hate when I mess up. So it'll be a little negative. This one's like negative point whatever. This is 1 minus 2 over square root of 3 comma 0. Toughly. That's a toughie. And then the other guy that's over here is like 1 plus 2 over square root of 3. So I have approximated the numbers a little off. Okay? But you can kind of see it. Like, there you go. Boom. Boom. Okay? Even the ugliest of numbers, we can still handle it. Okay? And don't forget, if they were imaginary, they wouldn't exist. Okay? So I just wanted to take the time. It was a quick 8-minute video, but I do feel like it was a good overview to know that you could have things that could be kind of tricky, but not kind of tricky at the same time. All right? Just stay consistent. Label your graphs. Make sure that you know where the numbers come from. Justify them to yourself. You'll be fine. All right, guys. So I want to go over that one last example. All right. Deuces.